I think in the next few years, what we're going to see is now we're observing basically the dawn of data. Now data is becoming available on everything. And on the other hand, we have the rise also of more deeper and more complex computational tools like deep learning, neural networks, large-scale data science systems. I think the next big challenge is how can you actually combine both, right? Because right now what you have is mostly systems that are focused either on handling the data, so systems like Hadoop, Spark, type of thing, and systems dedicated to very high performance computing with state-of-the-art CPUs and GPUs, and now even TPUs like tensor processing units. And how can you actually combine these two and make a system that is actually able to take advantage of both trends and put them to work together? I see GSS, or Global System Science, somehow as being an application of this high-performance computing and this large data science trends applied to studying large-scale systems and large-scale behavior. In particular, because it's what I'm more interested in studying how human behavior evolves and changes from place to place, and how people interact and move from one location to the other. So I think global system science can obviously get a lot from high-performance computing and getting the tools and the techniques from it. But also high-performance computing, in a sense, can be informed by the type of problems and questions that global system science is trying to ask and try to tailor more, at least some of its development in that direction. Pandemics, I think, is probably the most prototypical example of this application of global system science, right? It's something that impacts our lives directly, impacts our health in particular. And it's also dependent very much on how we travel, how we move, and how we interact with each other, right? Because diseases will spread from person to person when they are in contact, and people come in contact for various reasons, and even across the world, right? Because it's much more easy to travel now. So I think, as a prototypical example, it will help guide also the tools and techniques from global system science, and it's an obvious application in the sense of these high-performance trends, because if you want to do state-of-the-art simulation, state-of-the-art understanding of epidemics, and in particular real-time forecasting of epidemics, so if you want to know, okay, based on where the cases, let's say for Zika, are today, where it's likely to have cases tomorrow, that type of almost like a weather forecast, then you really need to handle large quantities of data in real time, but also large computing capacity to be able to, using the data, analyze it and perform simulations to try and forecast what's going to happen in the next few days or the next few weeks.